So good morning, everyone. Welcome to this special session. And in this session, we were discussing thermal expansion. I think we had discussed linear expansion in the previous class. Do we remember this?
Yes, sir.
What happens when we increase the temperature and if the body is one dimensional or taken as one dimensional, it will increase in length. Dl by d theta will be equal to alpha into the original length, and we had solved some problems. We had also seen what happens if alpha is a variable, if alpha is varying with temperature, how we have to find out the change in length. If alpha varies with length, then how we have to find out the total change in length. We had done some problems on it. We will try to wind up this chapter today. And the next thing, again, remember, we are dealing with expansion of solids. We are dealing with linear expansion of solids, to be very precise. Once we are done with this linear expansion of solids, then we will move on to areal and volume expansion, and then we'll move on to the liquid part. Now, the next thing that we are going to see, uh, remember all these points that we are doing, all these cases that we are doing, they are potential questions in themselves. Any one of this question, any one of this case might come in your exam, and you will have to know. So the next case that we are going to do is known as thermal stress. Now, what do you mean by this thermal stress? Ever heard about this term, thermal stress? Thermal stress is the next thing. Let us say, for example, we have a rod. Let me just not bring it here. Let us assume that we have a rod like this, and now if I, a rod or a wire, and if I increase the temperature of this rod, what will happen is it will expand. There will not be any thermal stress coming into it. It will just expand because it is free to expand. Now, if I do this thing, if I clamp this rod from one end, if I clamp this rod or I fix it to a wall from one end so that it cannot expand from the other end. Now, if I increase the temperature of this rod, again, since it is free to expand from one side, it will expand from that side, and there will not be any stress which is developed in the material. But if I do this case where I clamp it from both the ends, if I clamp it from both the ends, what will happen? If now I increase the temperature of this rod, it has nowhere to go. It cannot expand. If it cannot expand, that is the condition when thermal stress come into this rod. Do we understand this? So when the rod is clamped from both the sides, thermal stress is developed in the rod. To find out this thermal stress, what do? We find out the strain in this rod. Epsilon, the strain in this rod is the change in
Change
length
in length by original
upon
length.
original length. L0 we are calling it, and
Yes. Alpha.
that will be
Alpha
equal,
delta theta.
that will be equal to alpha into delta theta. From there, I can find out the stress developed in this rod. That stress
Y
developed in
alpha delta theta.
y alpha delta theta, that will be the thermal stress developed in the rod. Just remember these two things. If you remember these two things, this type of question can be done. Once again, remember one more important thing. If the temperature of the rod is increased, if theta is increased, what type of thermal stress is developed? Is it stress
Tensile.
which is tensile, or is it
Tensile.
stress which is compressive?
Tensile, sir.
No, it is not tensile, it is compressive. The stress developed is compressive. Why it is compressive? It is ulta, it is the reverse of it. Why it is compressive in nature? Because when the temperature is increased, this rod tries to expand, but it is not allowed to expand. So something is crushing it, something is compressing it. Therefore, the stress developed in the rod is compressive. If the temperature of the rod is reduced, it will try to contract, but the supports there will not allow it to contract. It will stretch it. In that case, that stress would be tensile. Do you understand this? Remember this in mind, because they might ask you a question where you might just answer in the opposite sense, and your answer would be wrong. Okay, do we get this?
Yes, sir.
Okay, then we can just solve a question based on this. Remember, whatever questions come on this, they are basically testing whether you know this concept or not. If you know this concept, the question is pretty simple, as the question that is here. Question is very simple. A steel rod is clamped at its two ends and rests on a horizontal base, fixed horizontal base. The rod is in its natural length at 20 degrees Celsius. Find the longitudinal strain developed in the rod if the temperature rises to 50 degrees Celsius. What is the longitudinal strain developed in the rod if the temperature rises to 50 degrees Celsius? And what type of strain is that? Is it tensile strain or is it compressive strain? Give you 1 minute to do this.
Ten power 5. 3.6 into 10 to the power of minus 5.
3.6 into 10 raised to the power minus 5 or minus 4?
Minus 4, sir.
Minus 4. So remember, because if they give this question in the exam, they will give you options. And one of those options may be minus 4, minus 5. You never know. So please be very careful. How do I get the thermal strain? To get the thermal strain, delta L by L. I don't have to do delta L by L. I can just do alpha into delta theta. I know the value of alpha. The value of alpha is given as 1.2 into 10 raised to the power minus 5. The change in length, the change in temperature, final temperature is 50, initial temperature is 20, change in temperature is 30. Multiply 1.2 by 30, and you have your answer 36 into 10 raised to the power minus 5, 3.6 into 10 raised to the power minus 4. Do we understand this? Everyone got this answer?
Yes,
Yes or
sir.
no?
Yes,
Okay.
sir.
Then we will move ahead and look yet another case where we use thermal expansion is used, and that is the time period of case number 2 is time period of pendulum clocks. Time period of pendulum clocks. What do you mean by time period of pendulum clocks? Now this pendulum clocks, they have a
Time
long,
taken by a pendulum to cover one oscillation.
yes, and they have a long what should I say, a bob which is hung from a long rod. Big pendulum clocks. Previously we used to only have pendulum clocks. Now time period of a pendulum clock is given
2
by
pi L by G.
2 pi L by G. Now this length, this pendulum clock is calibrated at a particular temperature, at a particular length. If the length changes, because the temperature changes, the time period also changes. Yes or no? Therefore, you have to understand what happens. So remember, what are you supposed to remember in this? When the length of the rod changes by change in temperature, the time period changes to T dash. Now this T dash can be written as 2 pi root over L dash by G. This L dash is the new length and this T dash is the new time period. Now once I solve this, I put the value of L dash in terms of L, alpha and delta theta, and then I expand it binomially and all that thing. I can land up with this formula, T dash minus T divided by T. I will end up with this formula. We are not going to get into how this formula is derived. We will get this result, and that result is important. T dash minus T divided by T is half alpha delta theta. Now this T dash minus t divided by t. You can write this entire thing as time gained or time lost per second. Do we understand this? This
Yes, sir.
entire thing, t dash minus t is time gained or time lost divided by t is time gained or time lost per second. So time gained or time lost per second by a pendulum clock is given by this formula, half alpha delta t, delta theta. Do we understand this? One more thing that you got to remember, because they might ask you as a option, if your temperature increases from the original calibration, what will happen? Will the clock become
Time runs
fast?
slow.
Will the clock become fast or will the clock become slow?
Slow. Slow.
Remember, clock will become slow. Clock becomes slow and it starts to gain time. If you remember one of the things, the other thing automatically comes. Why will it gain? Why will it become slow? Because the time period becomes more. When the time period becomes more, 1 second will be counted as 1.1 second. Sorry, 1.1 second. What it has to count at 1 second, it will count as more, and the clock gets slow. Time period becomes more. And remember, there is a term known as seconds pendulum. Have you heard about a seconds pendulum?
Yes, sir.
What is the time period of a seconds pendulum?
2 seconds.
Remember that time period of a seconds pendulum is 2 seconds. Do not forget it, because they might just ask you what is the time period of or they might just give you, there is a seconds pendulum, and you know what is the gain or loss in time when the temperature changes. Okay, so this is this, and you can do a simple question on this so that you can remember this concept of time gained or time lost by a pendulum clock. And this is the question, straight away, very simple one. Don't have to exert yourself. This is just to understand that once you understand a concept, if you get a question on that, it is a simple one. So a pendulum clock consists of an iron rod connected to a small heavy block. It is designed to keep correct time, and so it is calibrated at 20 degrees Celsius. How fast or how slow will it go in 24 hours at 40 degrees Celsius? Will it go fast or will it go slow? That we can first tell. Will it go fast or will it go slow?
No, sir.
Slow. That means the time period will increase. It will get slow. When it is 1.1 second, it will count 1 second because the time period has become 1.1 second. Okay, so it will go slow. How slow or how fast does it go in 24 hours? This is what the language of the question is like. This is how the language of the question is like. So, what is the answer for this one? Shall I do it?
1.03 seconds.
1.03 seconds. That I think is correct. How are we supposed to do this, everyone? How can we do this? So,
Half into alpha delta theta into 86400 seconds.
yes, so we have to remember that time gained or time lost, whatever the case is, per second is nothing but equal to half alpha delta theta. So this much time it will gain or it will lose in 1 second. We have to calculate how much time it will gain or lose in 24 hours. So you simply multiply this number by 24 hours. So time gain or time lost in 24 hours would be half alpha delta theta multiplied by the number of seconds in 24 hours. I think you should remember it as 86,400. Just a case of multiplication. If you can multiply them correctly, you will end up with the answer. The answer that I have is 1.04 seconds. And I hope that is the correct answer. Do we understand this? Yes or no? This is again one of the uses of linear expansion. A question on linear expansion may come from this category also. Then there is one more category which is known as true measurement. So the next category I will call it as measurement by a scale. Measurement by a scale or a rule. Now, if you are measuring a solid body, let us say if you are measuring the length of this pen, assuming it to be one-dimensional, by a rule or a scale. Now, this rule or scale sometimes is made up of metal. Now, what happens? The scale is graduated at a particular temperature. At that particular temperature, it will give you the correct value. If the temperature changes, if the temperature increases or temperature decreases, the distance between two markings, I don't have a scale here, the distance between two markings will change when the temperature increases. When the temperature increases, the distance between the marking increases. So it will measure small. Yes or no? Do you understand this? Longer things will measure small because the measurement between the distance between the two markings will increase. Similarly, the body which you are measuring, it might be measured at 20 degrees Celsius. Now you are trying to measure it at 40 degrees Celsius. This length also increases. Yes or no? So
Yes, sir.
if we take into, I will give you the most general formula. If you take into consideration both the change in the length of this rod and the change in the length of this scale, we can devise a formula which takes into account both of these factors. Remember this formula, just apply this and get away with it. True value will be equal to the measured value, whatever this has measured or scale reading, into 1 plus alpha into delta theta. That is the formula that you can apply. Now this alpha is alpha O minus alpha S. What is alpha O? This is the coefficient of expansion for the object that you are measuring. Alpha S is the coefficient of expansion of the scale that is measuring the object. If both of them, that is the most difficult question which has never come in a JEE. The only questions that I have seen in JEE where is there when the object does not change its length, only the scale changes its length. Only there is a change in the scale. But if they give the most tough question where the object also changes its length, then this is the formula you apply. If the object does not increase its length, alpha O becomes 0. Do we understand this?
Yes, sir.
So remember this. If you just remember this correctly, and if you remember the formula correctly, you should be able to solve any question that comes in this category, no matter how tough the question has been made or framed. Now, this type of question is more likely to come because this type of question usually involves two topics. So it is more likely to come in a JEE Advanced, where you have thermodynamics coming in, and they can put in some question of error in that measurement as well. For JEE Main or NEET, this question will come as it is, and it will not involve the change in length of the object. So question would be of this nature, where change in length of the object will not be involved. So this question will be for JEE Main or NEET. The other variation of the question would be for JEE Advanced. Even this question can come in JEE Advanced. It is no hard and fast rule that this cannot come. So this is the next question that we have. A bar measured with a vernier caliper. Since it has vernier caliper, we have all these things, error and vernier caliper and an instrument, and we call this topic as practical physics. Practical physics coming into it. A bar measured with a vernier caliper is found to be 180 mm long. The temperature during the measurement is 80 degrees Celsius. The measurement error will be if the scale of the vernier caliper has been graduated at 20 degrees Celsius. So how much is the error in measurement? Alpha is 1.1 into 10 raised to the power minus 5. Assume that the length of the bar does not change. So the scale has been graduated at 20 degrees Celsius, but it is used to measure at 10 degrees Celsius. What is the error in measurement? So this involves error. This involves thermodynamics. So now this becomes a question of JEE Advanced because it involves two topics and we have to find out the error. But any one part of this topic, any one part of this question is a question of JEE Main, or for that matter, NEET. I'll give you 2 minutes to do this. Shall I help you? Remember, in this question, it's the language of the question that is going to cause the maximum confusion, if I say. Shall I do it for you?
D, sir.
D, sir.
D.
D.
B, sir.
B, sir. Yes, it is B. How did you get B? That is correct. Well done. This is B. Correct. Question of JEE Advanced. Correct. How did you get? First things first, we have to find out the error. Now, what is error?
True value minus measured value.
True value minus measured value, right? True value minus measured value. Okay, the measured value is 180 mm. Yes or no? I just have to find out the true value. How do I get the true value? I already have given you this funda. Yes or no? True value is measured value into this. I just apply this, and I subtract this. So let me find out the error straight away, and you can use this as a formula. It is true value minus the measured value. So if I put the values, so true value is measured value into 1 plus alpha into delta theta minus the measured value. So measured value will get cancelled and the error will be simply measured value multiplied by alpha into delta theta. Do we understand this, everyone? This would be the error. Now to make this question more complicated, they can ask you what is the percentage error. So you can just find out the percentage error. Yes or no, divided by the value that is measured. Okay. That becomes a question of JEE Advanced. You just put the values, get the answer, and stay happy always. What is the measured value? The measured value is 180 multiplied by this alpha. Now, what is this alpha? This alpha is the alpha for the object, alpha of the object minus the alpha of the scale. But here the object does not change, so alpha of the object is 0. Minus alpha of the scale, so it is simply minus 1.1 into 10 raised to the power minus 5 divided by the change in temperature. The measured temperature is 10 minus the calibration temperature is 20. So that is the answer that you will get, my friends. I'm bad at calculation, so I think the answer will be this. I'm just taking it from the book. Do we understand this? Yes or no?
Yes, sir.
Everyone got this? Error. Vernier caliper. Thermodynamics. 3 topics getting mixed. This is the perfect recipe for JEE Advanced. 2 or 3 topics getting mixed. Recipe for JEE Advanced. This is how you make a question for JEE Advanced. That's it that you need to understand about linear expansion, and that takes us to the next heading. The next heading is known as what? Areal or superficial expansion. Now you might not get very tough problems here. The problems would be very simple. And if I just tell you, if I just show you a diagram, every one of you understand what is going to happen here. Now we will have 2-dimensional object. When I say 2-dimensional object, that means the object would have area. If you now change the temperature of that body, it is going to expand in length as well as in breadth. So you can see this gentleman is the original area. When the temperature increases, it expands. The final area, as you can see, is the outer one, which I have hashed in blue. This, whatever it has changed, the change in area, delta A, if I call it, this delta A will be equal to beta into A naught into delta theta. Do we understand this? Yes or
Yes, sir.
no? Or
Yes,
I
sir.
can write it this way also, dA by A is equal to beta into d theta if at all a question comes which involves variable beta and all those. You can write it all like this as well. Yes or no?
Yes, sir.
Okay, then you can find out the final area. The final area A will be A naught plus delta A. Beta is known as coefficient of areal expansion or superficial expansion. The formula still looks 1 plus beta into delta theta. This is the final area. Alpha is the coefficient of linear expansion. Beta is taken as the coefficient of areal expansion. Remember, we are talking about the expansion of solids. We have not gotten into the expansion of liquid. Do we understand this? We are
Yes,
only
sir.
dealing with expansion of solids. Once this is done, then we shall move on to expansion of liquids. A small question comes that locks this topic, this concept. Can I move on with the question?
Yes, sir.
This is the question, straightforward question. This type of question are more likely to come in a JEE Main or in a NEET exam. They might not come in JEE Advanced because this is straight away put the formula, get the answer, and stay happy.
Runs place previously.
What happened with the previous one? Aerial or superficial expansion. This is the previous slide. Noted it down? Shall we move on?
Yes, sir.
Okay. Then comes this question straight away. Just put the formula, get the answer, and stay happy. A plane lamina. Lamina means it is a two-dimensional body. Has area of 2 meters square at 10 degrees Celsius. What is the area at 110 degrees Celsius? Superficial expansion is given. Sometimes the only thing that they are going to do that instead of giving you superficial expansion, they will give you linear expansion. And that is how the questions are framed. They will never give you superficial expansion. So you must know a relation between superficial expansion, linear expansion, and the third thing, which is volume expansion. Yes or no?
Yes, sir.
If you don't know it, you can write it. Beta is 2 times alpha. What is beta? Beta is the coefficient of linear expansion. Beta is the coefficient of areal expansion. Alpha is the coefficient of linear expansion. Gamma is going to come in the next step. Gamma is the coefficient of volume expansion. This is 3 times of alpha. So you can write alpha as beta by 2, which is equal to gamma by 3. That is the only variation they will do in this question. Otherwise, there is no variation possible in this universe. Right now, they have not done this, so they have straight away given you the superficial expansion. Normally, for solids, always linear expansion is given. So from there, you can calculate superficial and the areal expansion or the volume expansion. Yes, what is the answer for this one? Straight away, put the formula, get the answer, stay happy. You can do it, yes or no? Again, whenever a question of thermal expansion comes, the only thing that you have to keep
2.008.
2.008. Okay. So A is equal to A naught into 1 plus beta into delta theta. Just put the values. A naught is 2 into 1 plus beta is 2 into 10 raised to the power minus 5.
Sir, 2.004.
Yes, I think 4 will come, not 8. Multiplied by 100. So if I multiply it by 100, this becomes 10 raised to the power minus 3. And you just add and multiply. I think you will get 2.004. Yes? 2.004, na?
Sir. Yes, sir.
I think that would be the answer. Be very careful with the multiplication part. You should do a very simple mistake. You will end up in trouble. You will end up in trouble. I hope you have done that, everyone. Got the answers?
Yes, sir.
Shall we move on to the third one? Third one is volume expansion for solids. For solids, it is also known as cubical expansion. Volume or cubical expansion of solids. So again, the small volume delta V that is expands will be del alpha into V naught into delta theta. We understand this? So I can write dV by V is equal to alpha into d theta. Same things, no change. V is equal to V naught into 1 plus gamma into delta theta. This gamma is known as the coefficient of volume or coefficient of cubical expansion. Do we understand this?
Yes, sir.
Okay. We have also seen the relation between alpha, beta, and gamma. Yes or no?
Gamma equals to 3 alpha.
Okay. Everyone understands this? Then we have this small question. Again, these type of questions are in fashion these days, whether it is JEE Main or advanced or in fact even NEET. Because again, these questions involve a bit of something which mixes up topics. I've forgotten the question number, so I call it question number 5. If the percentage change in length is 1%, with change in the temperature of a cuboid object, the length of the object is L, the width is 2L, and the height is 3L, then what is the percentage change in its area and volume? Simple, simple things, simple, simple thoughts, simple, simple questions. Yes, beta, any answer? Anyone got any answer?
Sir,
Yes.
change in area is 2%.
Change in area is 2%. That is correct. What about change in volume?
3%.
Change in volume is 3%. Change in area is 2%. Well done. Everyone got this answer? No one looks comfortable. No one got the answer. Only one hand I can see raised. That's it. What about the others? Everyone is looking at each other. Okay, I got 2 hands, 3 hands probably. Okay, look at this. It is simple. I'll also give you a different variation of the same question. Remember, it is said that it is because of the change in temperature. So basically, they have given the percentage change in length. Now, when I say percentage change in length, my dear friends, that is delta L, change in length upon original length multiplied by 100. Yes or no? And we have already seen delta L by L will be alpha into delta theta into 100%. Yes or no? And that is given as 1%. Now, if you understand this, then if I have to find out the percentage change in area, that will be delta A by A into 100. That basically becomes beta into delta theta into 100%. Now we know the relation between alpha and beta, everything else is same. Beta is 2 times alpha, so now the answer is 2%. Are we getting this?
Yes, sir.
That's it. Then we get the change in volume divided by original volume, percentage change in volume multiplied by 100. That will be equal to gamma into delta theta. That will be multiplied by 100%. So now I get 3%. These are the answers that we are looking at. Do we understand this?
Sir.
Everyone? Any doubt?
No doubt, sir.
Could give a different question though. Since I have seen this, if I give a different question though. If the radius of a sphere changes by 2% and things have happened. Strange things happen in life, and then we are all at sea. What to do, what not to do. Huh? What is this? What is this happening? Something not good. Now it looks better. Okay, let me bring it here, and here it comes. Okay, the change, if the radius of a sphere changes by, let us say 1%, find the change in area and volume. To the difference between the question. Let's see if we can do this. It's not given that it changes because of change in temperature. So it could change. I could change it by different other means. I've increased the area. I've decreased the area. I've increased the radius. I've decreased the radius. How does the area and the volume change? It's not mentioned that it changes by change in temperature. So you cannot use alpha, beta, and gamma. Do we understand this? It's not given that it changes by change in temperature, or so you cannot use the analogy of alpha, beta, and gamma here. But still, the question can come this way, and this can very well come in any of the exams, whether it is JEE Main, Advanced, or NEET. How do you do this? I'll give you 2 minutes to think about it. And once we do it, remember it, because in the examination hall, you're not going to solve it.
Sir,
Yes, bacha.
the 2%.
Area will change by 2%, and volume?
Calculating, sir.
Okay. Calculate it and tell me. And also, you did tell me how did you get the answer?
Delta
How did you
R
get?
by R into 100 equals to 1%. Sir.
Yes, beta.
Delta R by R into 100 equals to 1%.
That is correct.
Area equals to 4 pi R square.
Correct.
Delta A equals to 4 pi 2R delta R. Sir.
Okay. 4 pi.
Into 2R delta R.
Well done.
Delta A by A into 100 equals to 4 pi into 2R delta R by 4 pi R square into 100.
Excellent. That is correct. 2%. Well done. I was not expecting that anyone would solve this. This is good. Well done, bacha. Now, do the same thing for volume. Well done. Good. That is absolutely correct. Well done, beta. I'll give you 1 minute to everyone else.
Three percent sir volume.
3% volume. Change in volume is still 3%. Well done. That are the correct answers. Good. What about the others? I will still give you 1 more minute to redeem yourself. And if one student can do it, why not others? We can always take inspiration from just behind the corner. We don't have to look for inspiration above. You might not get inspiration from there, but you can get inspiration looking at your left and right. Well done. Okay, 1 more minute before I do what is necessary. Anyone else got the answer? Okay. Again, it might look like this is a bit out of the topic, but remember, we are doing a revision here. So if one thing comes up, I will make sure that if any question come on that category or that type or that looks like that, you should be able to manage it properly. How do I solve it? Okay, so what is given to me is delta R by R into 100%. That is given as 1%. Let me not use percent. Why I'm wasting time in writing percent? Delta R by R is given as 1. Let us say delta R by R is given as 1. Now I have to find out the change in area, percentage change in area and percentage change in volume for the sphere. Now I must know that the circumference area of a sphere is 4 pi r square. Now what I'm going to do is I'm going to differentiate this dA. If I find the derivative of this, it will be 4 pi into derivative of r square. The derivative of r square for NEET students, it might be looking a bit tougher, but it looks like this: 2 pi 2r into dr, r square 2r into dr. Now if I divide both sides by area A, if I divide both sides by area A, 4 pi r square, and this is what we always do. What happens is, my dear friends, 1r cancels, 4 pi cancels, and I end up with this 2 times dr by r. dr by r is basically your change in radius divided by original radius. Now this dr by r is basically given as 1%. So your change in area becomes how much? Straight away it becomes 2 times of change in radius. It becomes 2%. Do we understand this, everyone? So whether or not this is a question of expansion because of temperature, the expansion in area is going to come as 2 times the expansion in the radius, and that is how this derivation is also done. Relation between alpha, beta, and gamma is also arrived this way. If I have to find out the change in volume, so what do I do? First of all, I have to write what is the volume. So I skip the step. So let me first write what is the volume. Volume is 4 by 3 pi r cube. The volume is 4 by 3 pi r cube. I again differentiate this. So derivative of this will look like this: 4 by 3 pi into derivative of r cube is 3r square dr. I divide it by the volume. I divide it by the volume. So what happens? This term goes away. This term takes away the r square. So I'm left with 3 times dr by r. And again, this dr by r is given as 1%. My actual answer becomes 3 times dr by r. It becomes 3%. So this is how this feat is achieved. So you might treat this as a question of errors and measurement. You might treat it as a question of derivative. You might treat it as a question of thermal expansion. All roads lead to God, or all roads lead to Rome. Do we understand this, everyone? Can I have raised hands from everyone that we have understood this? Everyone in the class? Okay. That finishes our expansion in solids, and we move on to expansion in liquids. Do we understand this? We move on to expansion of liquids. And how do we how many types of expansion for liquid are? There's only one expansion for liquid, and that is volume expansion. For liquids, we cannot call it cubical expansion. Do we understand this?
Yes, sir.
So this is the formula for volume expansion of a liquid. Why I've written alpha here? I should have written gamma. So expansion in liquids is only expansion in volume, because liquids don't expand in length, they don't expand in area, they expand in volume. So whatever we had done for expansion in volume for a solid is the same formula also valid for expansion in liquids. Do we understand this? Yes or no? No, yes.
Yes, sir.
Please write it
Yes, sir.
again. In case of liquids, also in case of solids, One more expansion we can deal with, which is common to both liquids and solids.
Real expansion and apparent.
When you change the temperature of a body, the mass of the body does not change, but the volume of the body changes. Yes or no, my dear friends?
Yes, sir.
Therefore, one thing also changes. Variation in density. Now, this is valid both for solids as well as for liquids. So there are two things that are valid both for solids and liquid. One is expansion in volume or volume expansion. The second thing is change in density. Change in density. And what is the formula for change in density? With increase in temperature, the density should decrease. Yes or no?
Yes, sir.
So this is the original formula. D is equal to D naught upon 1 plus gamma into delta theta. If you do not want to write it in this form, you can write it in this form. Because gamma is very, very small, you can write it by using binomial expansion, and this becomes a formula for density as a function of theta. With change in temperature, density decreases. You can write it as d naught divided by 1 plus gamma alpha theta, or you can write it as d naught multiplied by 1 minus gamma delta theta. They both are coming from the binomial expansion. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay. Then you might have heard about anomalous expansion of water. Yes or no? So you can just note this down. Anomalous expansion of water. What do you mean by anomalous expansion of water? This thing has been asked in many times. Anomalous expansion of water. Anyone can tell me? Anomalous expansion of water. Tell you, bacha. With increase in temperature, what should happen? With increase in temperature, what should happen? For water. If I have water at 0
The
degree,
water contracts up to 4 degrees Celsius and then expands.
the water contracts up to 4 degrees Celsius and then expands. That means the density of water or the volume of water, if I increase the temperature from 0 degrees Celsius up till 4 degrees Celsius, instead of it contracting, it expands. The density of water is maximum at 4 degrees Celsius. This is known as the anomalous expansion of water. Do we understand this? After 4 degrees Celsius, if you heat up water, it is going to expand and the density is going to decrease. Now, because of this anomalous expansion of water, you see what are the effects of this anomalous expansion of water? Lakes always freeze from top to bottom. Do we understand this? So, because of this anomalous expansion of water, lakes freeze from top to bottom. From top to bottom, and this saves the aquatic life even in severe winters. Lake starts to freeze from top to bottom and it saves the aquatic life which is way beyond the surface. And the temperature below that snow, that ice still remains somewhere around 4 degrees or 5 degrees Celsius. So that has saved aquatic life from severe winter, and probably that is the reason that we are both alive, because if aquatic life would not have weathered that severe winter, there was some winter some millions of years back, everything would have ceased to exist. Do we understand this? Okay, now you can use this concept of expansion of liquid and expansion of solids together. Now, what happens when you have a beaker and you are putting a liquid inside the beaker and you are heating up the beaker, what happens is the beaker also expands. At the same time, the liquid also expands, but you hardly see the expansion of the beaker because the expansion in beaker is very less. You only see the expansion in the liquid, and whatever expansion you see is not the real expansion of liquid. It is known as apparent expansion of liquid. Why it is known as apparent expansion of liquid? Because the real expansion of liquid gets somehow burdened by the expansion of the solid. The solid also expands, the liquid also expands. So whatever we see is actually the apparent expansion of liquid. How I'm going to explain it is using simple thing. If I have a beaker completely filled with a liquid, and I'm going to draw that beaker. If I have a beaker which is completely filled with a liquid like this, the heading is apparent expansion. Apparent expansion of liquid in a beaker. This is a beaker. Let us say the volume of the beaker or the container is V0. It is completely filled up with this liquid. This beaker has a coefficient of expansion, let us say gamma C, container, C standing for container. Now this is completely filled up with a liquid. Let us say the expansion is gamma L. Now, if I increase the temperature or if I change the temperature by delta theta, if I change the temperature of this combination by delta theta, liquid expands. So what is the volume of liquid that you will have? The volume of liquid that will be equal to V0 into 1 plus gamma L into delta theta. That will be the real volume of the liquid. But the volume of the container or solid will also change. So its volume now becomes V0 into 1 plus gamma C or gamma S, if you call it solid, into delta theta. Now, what happens is if it is completely filled up, it will start to overflow. Yes or no? It will start to overflow, and that is the expansion that you see. So how much volume of the liquid overflows? The volume of the liquid overflows will be the volume of liquid, actual liquid, minus the actual volume of the container or the solid. Now, if I subtract both of these, what will I get? I will get this as like this: V0 into gamma L minus gamma C into delta theta. This gamma L minus gamma C can now be written as V0 into gamma apparent delta theta. This gamma apparent is known as the coefficient of apparent expansion of the liquid with respect to the container. Do we understand this?
Yes, sir.
That's all that you need to understand about the apparent expansion. What I have written here, my dear friends, in this color, this is the real expansion of liquid. Do we understand this? This is what the liquid really expands in this color, whatever color this is. In yellow color, what I have written is the real expansion of solid. In pink color, what I have written is the apparent expansion of liquid with respect to the solid or with respect to the container in which it is kept. Do we understand this? Is it clear to everyone in the class? Someone asked me a doubt on this as well. Was I think a doubt on this topic only. Do we understand this thing? Now we'll do a couple of questions because this is how the question might come. Are we ready for the questions? So I'll give you a couple of questions, and I think that should settle the debate about this one. And remember, for solids or the container, they might not give you the value of gamma. They will give you the value of alpha. Okay, my dear friends, are we ready for the question? Huh?
Yes, sir.
Yes, sir. Then give me the answer to this one, sir. Remember, whenever question of this nature comes, it is more a question, more a matter of your calculating things correctly, putting them correctly, and getting the answer correctly. Let us see who gives me this one. A glass vessel of volume 100 centimeter cube is filled with mercury, completely with mercury, and heated from 25 to 75 degrees Celsius. What volume of mercury will overflow? Coefficient of linear expansion of glass is given. Coefficient of linear, no. Volume expansion of mercury liquid is given. What volume of mercury will overflow? Give you 2 minutes to solve this straight away. It's very simple.
One point eight into 10 to the power of minus 6
Yes,
meter.
beta. Do you have an answer?
1.8 into 10 to the power of minus 6 meter.
1.8 into 10 to the power minus 6. The answer that I have is 0.87 centimeter cube. 10 to the power minus 6 is meter cube probably. The answer that I have is 0.87. I may be correct, I may be wrong. I don't know. Have you considered that see, that is the mistake that everyone makes. Did you realize that for glass it was given as linear expansion and not volume expansion? Did you take it as linear expansion or volume expansion?
Consider linear expansion into 3.
Okay, then there must be a problem with the calculation part, which also I am not good at. So what I am going to do is solve it and just put the formula, get the answer, and stay happy. So the amount of liquid that will overflow will be V naught into gamma L minus gamma container or gamma solid. Let me that is gamma solid into delta theta. I will just put the values. V naught is 100 centimeter cube. Then I have gamma liquid. Liquid is 1.8 into 10 raised to the power minus 4 minus 3 into 1.8 into 10 raised to the power minus 6 multiplied by the change in temperature is 50 degrees. You just have to calculate this. What is the answer? I'm not good with calculation. I have told you that, right? Whatever the answer comes, that is the correct answer. What is the answer that you're getting?
0.897.
0.89, sir. The book says 0.87. So that is the answer. Remember, be very careful about this power. This is 10 raised to the power minus 6. This is 10 raised to the power minus 4. And this is multiplied by 3. If you keep all these things in mind, I think you should do good enough to solve this question. Do we understand this?
Yes, sir.
Everyone understands this? Okay, as I told you, I'll give you a couple of questions on this. So the next one is like this, so that this concept gets clear, because most of the cases students are going to make mistakes in this type of questions only. This is the next one. Remember, the only thing that we are going to check is whether you are calculating things correctly or not. The volume of a glass vessel is 1000 cc at 20 degrees Celsius. What volume of mercury should be poured in at this temperature so that the volume of the remaining space does not change with temperature? Interesting one. The volume of the remaining space does not change with temperature. This is a question that can come in all the exams. Forgotten the question number, I will call it question number 7. The volume of the remaining space. We had done a similar question in linear expansion of solids. Yes or no? I think we had done a similar question. If you can remember that question, you should be able to solve this one. I'll give you 2 minutes to solve this. Yes, my dear friends, do we have an answer? It requires some calculation, nothing else. Nothing else more than the calculations. Shall I do it?
So we are trying, sir.
Okay. Give you time.
Five thousand cc, sir.
Sir, 4 into 10 to the power 5.
Cannot be 5,000 cc beta because the total volume is 1,000 cc. So 5,000 cc is more than 1,000 cc. It cannot be. Yes, beta. Anything else? Any other answer?
4000 cc.
4 into 10 to the power 5.
4 into 10 to the power 5. 4 into 10 to the power 5 cc. That is more than 1,000 cc. So I need to fill mercury 5 times or 4 times this volume so that it remains the things remain same. Okay, can you tell me what concept did you apply? Forget about the answer. Answer don't matter. Remember, when you get an answer, beta, also try to make sense. The total volume is 1,000 cc, so your answer cannot be more than 1,000. Yes or no? Your answer has to be very small compared to 1,000. Else it is not correct. Anyways, what is the concept that you applied? The volume of the glass vessel is 1,000 is given.
Sir, 50 cc.
50 cc is correct. 50 cc is correct. Who got 50 cc?
Sir.
You got you tell me 5,000 cc. Now you say if it's 50 cc. Power of zeros, my dear friend. Power of zeros. 1 0 can make a hell lot of a difference. So. What do we got to do here? Yes, tell me. How did you do it?
Volume of glass vessel equals to volume of H2 minus volume of remaining.
The remaining space ka volume should remain same. So if I just draw a very simple diagram of this is the original volume, which is 1,000 cc, volume of the container, or I can call it volume of the glass. And let us say that the initial volume that I fill of liquid mercury, I call it Vm, volume of mercury. Now, the volume of the remaining space, my dear friend, is Vg minus Vm. Yes or no? No or yes?
Yes, sir.
Now, that should remain same at all temperatures. That means that must be same as V dash G minus V dash M, where V dash G and V dash M are the volumes when the temperature is increased or decreased. Do we understand this?
Yes, sir.
That's it, my dear friend. Then we just put the value of V dash Vg into 1 plus gamma G delta theta minus volume of mercury into 1 plus gamma mercury into delta theta. And if you look closely enough, you will find out that, dear friends, that this 1G and 1Vg, this 1Vg will get cancelled, and this 1Vm and this 1Vm will get cancelled. And if you do dung, this dung, if you do, then you will get that Vg into gamma G into delta theta will be equal to Vm into gamma M into delta theta. Basically, what it means is the change in the volume of glass and the change in the volume of mercury must be same. Do we understand this? Yes or no? No or yes?
Yes, sir.
You just put the values, get the answer, and stay happy always. If you could have understood this, and if you could have remembered what we had done in the previous week, That was the question. The design of a physical instrument requires that there is a constant difference in length. Here it was constant difference in length. And you see, my dear friends, the same concept. The change in length of iron rod and the change in length of the copper rod must be same. Whether it is keeping the change in length same or keeping the change in volume same, conceptually they are similar questions. Yes or no?
Yes, sir.
So whenever such a question comes, my dear friends, please remember that we have done this and don't get scared. Okay? Do we understand this? Yes or no? No, yes?
Yes, sir.
Ah,
Sir.
okay. Let me now give you next question. The more the questions you do in this,
Sir.
I'll give you one last one on this. I think we have done enough, I think. One
Sir.
last one. Yes, beta.
I send you a question in Telegram, sir.
Beta, I don't remember that question.
I send again, sir.
Send it again. I'll see it and I'll discuss it. Okay? Don't worry.
Already send it, sir, now. Just now.
I can't see it, beta. I mean, trust me. I mean, it takes time for me to see it, right? Give me time for solve this question first. The coefficient of expansion of liquid in a copper vessel is C and a silver vessel S. The coefficient of volume expansion of copper is gamma C. What is the expansion of silver? Let me see your question. Where is that? How will I see it?
Once show previous slide.
Okay, you want to see the previous slide? Okay, see this one. Meanwhile, I will look at the question. Let me know once you are done so that we can move on to the next question. Where is that? Okay, Santosh, the question is pretty simple. What is the problem? Why to find the rise in water level, find the volume of water, find the volume of the vessel, subtract both of them, and you are done.
Completed, sir.
Okay. Get this better? Find the expansion in the water, volume of water, find the expansion of the vessel. We have done this. The only difference between our question and this question is that you have not sent the complete question, I think. Have you sent the complete question? Okay, let me first show this one, then I will go. Okay, do you see this question now? The coefficient of apparent expansion of a liquid in a copper vessel is C and in a silver vessel S. The coefficient of copper volume expansion of copper is gamma C. What is the coefficient of linear expansion of silver? Let us solve this question, then we will see into what that question is.
I have. Sir,
Yes, beta.
it is a complete question, sir.
Okay, okay, I'll check. Let's solve this one.
Okay, sir.
Sir, option C, sir.
Okay, let me see. Everyone has done this. Fast.
C equals to gamma L minus gamma.
Which one? Give me the answer first.
Option C, sir.
Option C, sir. Everyone is getting the same answer? Okay. The coefficient of expansion of liquid, apparent expansion is given, and you are supposed to find out the alpha for, I think, copper. And the answer is A, B,
C.
C. All of the options are looking similar to me. I'm getting confused. Which one? A, B, or C? Or D?
C, sir.
C, sir. Everyone got this? C?
Yes, sir.
How did you get C? How did you get C? Anyone?
Yes, sir.
Got it? How to get this? So remember the apparent expansion, alpha apparent, is gamma liquid minus gamma of the container.
Gamma
Yes,
container.
right. Now, in copper vessel, it is given as C. So C will be equal to alpha gamma of liquid minus gamma of copper. Yes or no? Then in silver vessel, I am not visible. This is visible. The whiteboard is visible to you. Yes or
Yes,
no?
sir. Visible.
Okay.
Clear.
For S, it will be equal to gamma liquid minus 3 times alpha of silver. Yes or no? From
Yes,
these
sir.
two equations, what you got to do from equation number 1 and from equation number 2, what you got to do is you got to eliminate gamma liquid and find the value of alpha silver. I hope you can do this. Yes or no?
Sir.
And the answer that we are getting is, I think, C plus gamma C minus S divided by 3. This is the answer that we are looking at. Do we understand this? Yes or no?
Sir.
Everyone understands this? Okay. Well done. That finishes this apparent expansion wala part, and one part is remaining. So let us first finish that one, and that is known as your effect of temperature on buoyancy. Do you know what is buoyancy? Just right. Do you know what is buoyancy? That is the last part of the thing. Effect of temperature on buoyancy.
Upward force applied by the liquid.
Okay.
Exerted by the liquid.
Fatafat, tell me what all things you know about buoyancy. Since we are doing this effect of temperature, we can just finish this small part because there could be a small question coming from this. What do you mean by this buoyancy? Buoyancy is the upward force acting on the solid when it is immersed inside liquid. Yes or no? Do we understand this? Yes or no? The buoyant force FB. How much is that buoyant force FB?
mg.
Huh? mg?
G sir, Viroji.
It is the volume of the solid which is inside liquid multiplied by the density of the liquid multiplied by G. Do we understand this?
Yes, sir.
For equilibrium, for the liquid to float and a solid to float, the condition must be the buoyant force must be equal to the weight mg. Do we all understand this?
Yes, sir.
Okay. This is the first thing that you must understand. Now, what happens? What happens when the temperature increases? The volume of the solid also increases. Yes or no?
Yes sir.
Now, when the volume of the solid increases, the volume of the solid that is inside the liquid also increases. But the density of the liquid decreases. Yes or no? So, if I find out the volume of the body, the new volume V dash, which will be inside the liquid, and the new density of the liquid, so I can write it like this. Let me use a different color pen. The new volume V dash, which is inside, will be given by the original volume into 1 plus gamma of the solid multiplied by delta theta. Do we understand this? At the same time, the density of the liquid, it has now decreased. It becomes original density divided by 1 plus gamma liquid into delta theta. Because of this, what happens, my dear friends, is that the buoyant force changes. And how much does the buoyant force change? If I say the new buoyant force is F dash, original buoyant force is F. The original buoyant force is given by VL dl into G. The new buoyant force is given by VL dash dl dash into G divided by VL into dl into G. If I do this, I will get this formula, and remember this formula. This is the effect of buoyant force. This is the effect of temperature on buoyant force. Remember, this is the case when the body is completely submerged. This is case number 1. It is body is completely submerged. When the body is completely submerged, this is the case. The entire body is inside, and we will get this condition that the buoyant force on the body will change. Okay. Then there is a case where the body is floating. Students normally get confused between the two cases. First case, when the body is completely submerged. Second case, when the body is floating. Let me just give you a question. Have we written this? Have we noted this down, bacha?
1 second sir.
Please note it down, beta. Give you 2 minutes to note it down.
Noted, sir.
Done, sir.
Noted, sir.
Okay, then solve this question, beta. A body is float inside a liquid. If we increase the temperature, then what changes occur? Yes, I'll give you 1 minute to think about it.
Sink, sir.
Yes, beta? Same or different? Mm-hmm.
Body will sink, sir.
Body will sink, sir. See, it is given body is in floating condition, my dear friends. Isn't it? See, that is what you have to remember. In the case that I had given to you,
Buoyancy force will decrease.
okay, do one thing. I think probably just do one thing. I think I've confused you here in this case. This was case number 1, and for this case number 1, just don't write this. I think you got confused with this. For case number 1, the
Rho
body.
L is greater than rho S.
Chill. First, see what I am. First, listen to what I am telling you. Okay. This case number 1, when the body is completely submerged, this VL is the total volume of the solid. The volume is completely inside. Think you have misinterpreted what I have said. So let me correct it first. This is the total volume of the solid. It is completely submerged. Okay. Now remember, before doing this case, let me go on to the case where the body is floating. Now, what happens when the body is floating? For body to float, what is the condition? Yes, tell me. For body to float, what is the condition? For body to float, what is the condition, my dear friend? Tell me. For body to float, what is the condition? For body to float, the condition is very simple. The buoyant force must be equal to mg. Yes or no? Do we understand this?
Sir.
Yes or no?
Yes, sir.
Now what is the answer? A body is float inside liquid. If we increase the temperature, then what changes occur in the buoyant force? Assume that the body is always in floating condition. Now tell me your answer. What is your answer, my dear friends? What happens to the buoyant force? Does it increase? Does it decrease?
It will just flow.
Yes, bacha? Does it increase? Does it decrease? It remains same. Do we understand this? Because the body is still floating. The body is still floating. If the body is still floating, the buoyant force must be equal to the weight of the body. In previous case also, it was equal to the weight of the body. So, if the body has to remain afloat, both the buoyant force must be equal to the weight. Do we understand this, everyone? Please raise your hands.
Yes, sir.
But something has to change. Now the question comes, something has to change. What will change? Either the body will go down more, or the body may come up. Do we understand this?
Yes, sir.
Do not confuse it with the first case. Probably I confused it with the first case. I confused you with the first case. In the first case, body was already down, already sunk inside the liquid. Nothing was going to happen. In this case, the body is afloat. If the body is afloat, the buoyant force remains same. The only thing that is going to change is whether it goes down more or it comes up. Do we understand this? Yes or no?
Yes, sir.
Okay. Now, if I say that in first case, the volume submerged, in first case, the volume submerged was V1, and in the second case, the volume submerged, that is inside, is V2. In first case, the volume submerged is V1. In second case, the volume submerged is V2. Remember, buoyant force should be equal to the weight. So V1 into the density of the liquid D1 into G should be equal to V2 into D2 into G. Do we understand this? Yes or no? No or yes?
Yes, sir.
Do we understand this?
Yes, sir.
Yes, sir.
Okay, then we call this F1. This F1 is V1 divided by V0. What do you mean by this? F1, this is the fraction which was immersed before. F2 is the fraction which is immersed afterwards. The fraction which is immersed afterwards will be V0 into 1 plus gamma S into delta theta. Do we understand? Now, it might look very typical, but if you understand it point by point, it becomes very simple. So basically, this is the fraction which was immersed before. This is the fraction which is immersed afterwards. I can write this F2 again as, I can substitute V1, V2 in terms of V1. I can write it as V1 into 1 plus gamma L into delta theta divided by V0 into 1 plus gamma S delta theta. Depending on the value of F1 and F2, we can find out whether the liquid has gone, the solid has gone down or the solid has come up. Do we understand this?
Yes, sir.
So what you got to remember here, beta, are three things. First is this, the pink one. Second is this, the first fraction. And third is this, the second fraction. Such a typical question should not come. But if it comes, this is how it is solved. If I give you a hint from this, if gamma L is greater than gamma S, the body will move downwards. Just remember one thing, and the rest of the things will automatically come. If gamma L is greater than gamma S, body will go down. If the reverse happen, which is impossible because gamma of the liquid cannot be less than gamma of solid, if by chance a question is made, then the body will come up. Body will never come up because the density of the liquid is going to go down and the volume of the solid is going to increase. So body will never come up, body will always go down. Do we understand this? That is
Yes,
all they
sir.
are going to ask. They are not going to ask you all these things. This is just beyond the time that you get. Do we understand this, everyone?
Yes, sir.
Okay, then what I'll do is I've got a doubt and I will try to take this. Let me see if I can put that thing on the board. So we are done with your thermal expansion as such. And oops, can I? Okay, image. I can probably put it here on this board if I can. Let me try to put this on this board. Oops, it's just too much. Oops, oops, oops. It has done a lot of damage to my thing. I just can't do it. Just can't put it. But this has done a lot of damage to what I was doing. Okay, what do I do? I can't put it here like this. Okay, so what I do is I will show it as an image to you because that is the only thing I can do. If I put it here, I will just make it worse. Where is that? Okay, I can't do it this way. Let me try it. Forward pin. There is no point of saving it. Copy image. Save as. Okay. Save as downloads. Save. Okay, let me see if I can show it to you. Photo. Okay. Let me see if I can do this. I don't know whether I can do this. Share. Okay, can you see this? Oh, can you see this? So this was a question sent by you. An aluminum can of cylindrical shape contains 500 centimeter cube of water. The area of the cross section of the can is 125 centimeter square. All measurement refers to 10 degrees Celsius. Find the rise in the level of water if the temperature increases to 80 degrees Celsius. The expansion of aluminum is 23 into 10 raised to the power minus 6, and the expansion of water is this one. Okay, how are you supposed to do this? We have to find the increase in the level of water. How do I supposed to do this? How are we supposed to do this? Yes, any ideas? How are we supposed to do this? So, yes, beta, how are we supposed to do this? Have you seen the question? Where is the question? Even So, first of all, we find out how much what? How much is the final volume of the water? Can you find out the final volume of the water? Yes or no? 500 into 1 plus gamma into delta theta. Can you find out the final volume of water?
Yes, sir.
Okay. What is the final volume of the water coming? Just calculate it. Once you get the final volume of water, we can find out how much is the increase in the volume of water. Yes or no?
Yes,
Please raise
sir.
your hands. You can find out what is the increase in the volume. Final volume minus initial volume, you will get the increase in volume. You have to find out how much the level of water has raised. As you can see, the expansion in aluminum, it will only expand in length, right? We'll take it as expansion in length. So what we'll do is we can neglect the expansion in area. Whatever increase in the volume of water we have got, we divide it by the area of the cross section. That should give us the rise in the level of water. If I have to, again, I will have to change. Let me change it. New share. Have you seen the question, everyone? Have you seen the question, everyone?
So once please open the question.
But the thing is that is on a different screen. Okay, let me just do it in this way. I will just tell you what all things are given. So the first thing that is given is volume of water is given as 500 centimeter cube. Okay, so you find the final volume of water 500 into 1 plus gamma L into delta theta. Change in temperature is also given. From there, you find the change in volume. Do we understand this? From there, you find the change in volume. The dimensions of, from there, you find the change in volume. Do we understand this? And then, if you have to find out how much the volume has risen, you divide it by the area of the base. So you will get the increase in the height of water. Do we understand this? The question is here. I have to change screens for that question. That is the problem. Okay. Chalo, then I will finish this class here. If you have any doubts, it's better that you can send me on the Telegram group, and it becomes difficult for me to put it here. I will try to solve it in the Telegram group only. That would be better. Okay. Or I'll try to put it here, because then it becomes very difficult for me to manage from here to here and all that. Okay. So I'll do it in the next class. If you have any doubts from this chapter, please try them at home. Okay. Take care. Bye bye.
Bye, sir.